For this project, what we'll need is the printout available online. You'll need some scissors, a pencil, 2 or 3 other colors. Notice I chose red and blue, and then I have purple here because there's parts where the red and blue will overlap. And then a twist tie or a tack or a brad, something that is going to hold the circles together. That will make sense in a little bit. Our first step is going to be to cut out our shapes. But before we do that, I just wanted to point out a couple of things about these shapes. So if we look at our triangles, notice there are actually 2 blue triangles here, but together those 2 blue triangles make one big equilateral triangle. So we know that an equilateral is 60, 60, 60 as the angles. So we know that this angle is 60 degrees. This angle is 60 degrees. That means this angle will be split into a 30 degree and 30 degree because these will be our right angles. Okay, so just so we can kind of visualize that we're splitting an equilateral triangle in half to get 2 30, 60, 90 triangles. Now I'm going to go ahead and cut out the triangles, and I'll show you a trick for cutting out the circles as well. So I've gone ahead and cut out my triangles. To cut out the circles, there's a little trick that I like to use, which is that I'm going to fold them in half before I cut them out. And in half for a circle just means as long as the edges match up, no matter which way you fold it, because of a circle has infinite symmetry, infinitely many lines of symmetry, that will automatically be in half. So now instead of cutting around the entire circle, I only have to cut around half of the circle. Now, if this circle wasn't here, I could fold it in half again to only have to cut around a quarter of the circle. But if I do that, I'll be folding this circle, and I don't want to do that. I only want to fold my circles into perfect quarters. So for this, I'm going to cut out the half circle. For the next one, I will cut out a half circle, and I save the biggest one, I'll fold into quarters to cut it out. All right, so now I have my triangles and each of my circles cut out. The next step is to fold the rest of the circles into quarters. So right now, only my biggest circle was folded into quarters. I'm going to take my other 2 circles and fold those into quarters as well. And this way we'll be able to layer our circles. They'll all fit nicely one on top of the other. And the reason we're folding them into quarters is that they will represent the 4 quadrants of our Cartesian plane, but also we now know where the exact middle of our circles is. So what we want to do next is punch a hole through the middle of the circles and the center of the coordinate plane. And this is where that brad or twist tie will come in. So I'm going to go ahead and put the hole, and then I'll show you the next step. Okay, so I used a pen just to poke a hole through the middle of the circles and the middle of my graph. And now what I want to do, if you have a brad, it's already set up for this, but I'm going to go ahead and tie kind of a knot in the middle of my twist tie. And that's going to prevent my twist tie from pulling all the way through my hole that I just made. And then I'm going to kind of flatten it down. So now it's essentially a brad where I have the head and I have kind of the 2 arms. So I'm now going to push this, the 2 arms, through the holes that I just made in the circles as well as our graph paper. And once that's done, we're going to flip it over and flatten out the wings so that it won't fall back out. So now I have my circles attached to my graph paper. Okay, now we're going to look at the triangles for a second. So I'm just going to turn this upside down here to look at our triangles. We have here 2 30, 60, 90 triangles. I'm going to turn one of them so that I can hold the 60 degree angle and a 30 degree angle at the same time. And then we're going to look at our red or pink triangle. Now notice this triangle also has a right angle down here at this bottom corner. And this is actually an isosceles right triangle, or a 45, 45, 90 triangle. So this is our other special right triangle. That means this is a 45 and 45 degree angle on each of our bases. So I'm going to take this, I'm going to put it between my two blue triangles. And what we've actually just created are each of our parts of the unit circle, each of the special angles that we're going to look at. So I can put these triangles kind of along the inside of my circles, and we've just created a unit circle. Now, this is only one quadrant of the unit circle, but because the unit circle repeats itself in each of the four quadrants, I can actually take these triangles and just flip them upside down or rotate them to get the second quadrant of the unit circle. Now, in this case, our triangles are not the reference triangles. We'd have to do a little bit of adjusting where we hold our 30, 60, 45 angles and kind of flip them around a little bit so that they're resting on the x-axis to be what we call reference triangles. But even without doing that, notice our lines are still the same, blue, pink, blue. If we flip them back to the way they were originally and rotate, we do the same thing with blue, pink, blue. Okay, so we can use these triangles to create each of our four quadrants. So our next step is going to be to take one of our triangles and lining up your folds with your axes the best that you can. I'm going to go ahead and draw in my X and Y axes. Sorry about the lighting. And then using my colors, I'll draw in my angles. So I'm essentially using this triangle kind of like a protractor. Using the triangle to draw a 30-degree angle there. And then we can draw a 30-degree angle from the y-axis here. And notice that would make a 60-degree angle from the x-axis. And then we'll do it here. And here. Now what we've just done is we've created spokes of our unit circle. And if you look at those four spokes, they actually make right angles with each other because we were just rotating that triangle 90 degrees each time. I'm going to take my other blue triangle and do the same thing. So here's my 60-degree angle. Rotating it here is 60 degrees from my y-axis or 30 degrees from my x-axis. $60 degrees here. And 60 degrees here. And finally, I'll switch colors to do my red, or you could call it pink triangle. Again, placing the 45-degree angle against the origin. And here is my 45-degree angle, which is halfway between the X and the Y axis. And this one's nice because I can just go ahead and switch which way the triangle faces to create a 45-degree angle in whichever quadrant I am drawing in. That's nice about an isosceles triangle. And the last one here. Okay. So I'm going to show you kind of a couple of patterns on here. If we look directly down from the top, you should notice that these blue angles happen every 30 degrees, right? So from the x-axis, we go 30 degrees more. So that's 30, 60. So following that pattern, this line should be blue. 30, 60 blue. So our axes should be blue. But if we look at that pattern for the red lines, starting at the x-axis, we go 45 degrees. So another 45 degrees takes us to the y-axis. So our axes should also be red. And that's why I have this purple marker, because if I put red and blue on the same line, that line would be purple. So I'm going to go ahead and color over my axes in purple. Now I know this is not perfect, but the idea is to kind of start seeing patterns and things like that, so it doesn't have to be absolutely perfect. Okay, so we have all the spokes of our unit circle. Now the reason we have 3 circles moving outward is because I'm going to use each of those spaces to put a different property of our unit circle. So the first thing I'm going to do is put degrees, and I'm going to put that right on the outside of our smallest circle. So on the x-axis, our angle from the x-axis would be 0 degrees. Or if we think about it as going all the way around the circle, that's also 360 degrees. In the second spoke here, this blue line, we've now gone from the x-axis 30 degrees. The red one will be 45, 60, 90. From 90, we go 30 more. So that would be 120 degrees. I'm just going to continue all the way around the unit circle. Okay, the next thing we're going to do is fill in radians. Now, radians is usually a less familiar concept, but remember, a radian measures an angle with relation to the circumference. So the circumference of a circle with a radius of 1. If our radius is 1, because that's the definition of a unit circle, then the circumference is 2 pi r, which is 2 pi times 1. So 1 full rotation, circumference is 2 pi. The angle is 2 pi. So a radian is the measurement of an angle with respect to the circumference, whereas degrees, 360 doesn't mean anything to the circumference of a circle, right? So radians are a new way, or a newer to us way of measuring angles that takes into account other properties of the circle. So when we're looking from the x-axis, the angle from the x-axis to the x-axis again is 0 or 2 pi. I can look at it as going all the way around the circle, just like 360 degrees. Notice radians don't have an indication. It doesn't have a symbol to mark radians. So when we're working with angles, if there's no symbol, we assume that it's radians. If there is a symbol, then it's degrees. Then we go up to our next line. Well, that's not the easiest next part to look at for radians. If a whole circle is 360 degrees, that's 2 pi radians. then half of a circle would be half of 2 pi radians. So let's go ahead and mark radians for our 180-degree angle. Half of a circle is pi radians. Okay, so if a full circle is 2 pi and half of a circle is pi, then 1/4 of a circle will be half of pi, or pi over 2. Well, then the bottom angle here will be half of a pi, full pi, 1.5 pi, or 3 pi halves, 3 pi over 2. Okay, so notice I kind of counted by quadrants. 1 quadrant is pi over 2 radians. So I'm going to add that down here. 1 quadrant angle is pi over 2. This is radians. We don't have to write the word radians, but I'm writing it for the sake of note taking. Okay, so let's focus on quadrant 1. From 0 to pi over 2, that was 1 quadrant. Well, 45 degrees is halfway between that. So half of pi over 2 is pi over 4. Okay, the blue lines indicate thirds. We have 30, 60, 90. So we cut our quadrant into 3 pieces. So if I take pi over 2 and I take 1/3 of pi over 2, that would be pi over 6. So this is pi over 6. If pi over 6 is 30, 30 plus 30 would be pi over 6 plus pi over 6, or 2 pi over 6. And 2 pi over 6 simplifies to pi over 3. So our radians there are pi over 3. So that means I have 1 pi over 6, 2 pi over 6, 3 pi over 6 does simplify to pi over 2. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Notice I'm counting just the blue lines now. Purple counts as a blue line and a red line. So that was 4 pi over 6 simplifies to 2 pi over 3, which came from 4 pi over 6. So the next blue line should be 5 pi over 6, which does not simplify. And then 6 pi over 6 simplifies to just pi. And then 7 pi over 6. 8 pi over 6, which again, we can simplify. So we have 8 pi over 6 simplifies to 4 pi over 3. 9 pi over 6 simplifies to 3 pi over 2. So that was 9. The next one would be 10. So this is 10 pi. Oh, I'm going to simplify that. 10 pi over 6 simplifies to 5 pi over 3. So notice all of the ones that are closest to the y-axis we're able to simplify. So that was 10. Our last one is 11 pi over 6. Okay, so we took care of all of our blue angles. Now let's look at our red ones. So for the red angles, we had pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So we found the radian angle measurement for all of our special angles of our unit circle. Now, this is not to say these are the only angles of the unit circle, right? I could fill in any angle here, and it can be an angle of the unit circle. But these are our special angles of the unit circle. Okay, so we filled in our degrees, we filled in our radius. The last thing we want to do is fill in the coordinates. To fill in the coordinates for the unit circle, we're going to look back at our special triangles. And because this is a unit circle, we're going to look at our triangles as if they have a radius or hypotenuse equal to 1. So we're going to say, okay, if these are all radii of our unit circle, then this hypotenuse has to be 1, 1, 1. Because it's a unit circle, meaning the radius is 1. Okay, so then how do I find the side lengths of the triangle? Well, if this is a 45-45 right triangle, for a 45-45 or an isosceles right triangle with a hypotenuse of 1, we know that the side lengths have to be the same. So let's call this S. Then this side length is also S. Then by Pythagorean theorem, S squared plus S squared equals 1. So 2S squared equals 1. I should say 1 squared. Then S squared equals 1/2. Then we can use the square root property to say that the square root of S squared equals plus or minus the square root of 1/2. Now, S is a length, so we choose only the positive because it's a distance. Then S equals the square root of 1/2. We don't like to leave our fractions inside of a radical, so I'm going to multiply this by the square root of 2 over the square root of 2. Remember, that is called rationalizing to get the square root of 2 over 2. So now we know for our pink or red triangle, each of our side lengths is square root of 2 over 2. Well, that means that if I take my triangle and I put it on my circle, then this point at the end of my triangle has the coordinates square root of 2 over 2, comma, square root of 2 over 2. So this has coordinates square root of 2 over 2, comma, square root of 2 over 2. Oh, well, can't I do that for all of my red angles? Sure. Here we go. That means that this point at the end here has the coordinates now. It is a distance of square root of 2 over 2, but it's on our negative x-axis. So that is negative square root of 2 over 2, comma, square root of 2 over 2. Hopefully you're starting to see a little bit of a pattern here. In quadrant 3, the point at the end will have negative x and negative y. So that's negative square root of 2 over 2, comma, negative square root of 2 over 2. And lastly, in quadrant 4, that's a positive x and a negative y. So that's square root of 2 over 2, comma, negative square root of 2 over 2. That takes care of our pink triangle. Okay, next let's look at our 30, 60, 90 triangle. And we're only going to look, because these two triangles are similar, right? I can put them face to face and the side lengths are going to be the same. So let's just look at one 30, 60, 90 triangle. There's 90. My smaller angle we'll call 30. Then this one is 60. And for this triangle, when we looked at it as half of an equilateral triangle, We know that our radius is 1. Then by special right triangles, we know that this is S, and this is S times the square root of 3. Then by Pythagorean theorem, we can say that the square of the legs, that's S squared plus S times the square root of 3 squared equals 1 squared. S squared plus, if I have S times the square root of 3 squared, that's S squared plus 3, or I mean times 3. 3S squared equals 1 squared. That gives me 4S squared equals 1. Divide by 4. S squared equals 1/4. Again, the square root property. So then the square root of S squared equals plus or minus the square root of 1/4. Of course, it's a distance, so we choose the positive one and rationalize equals, well, I guess we don't have to rationalize because the square root of 4 is just 2. 1/2. Okay, so that means that on our triangle here, this side is 1/2, and the bottom is that times the square root of 3. So that is the square root of 3 halves. Same thing goes for our other 30, 60, 90 triangle, except this bottom is now our S, 1/2, and square root of 3 halves. So let's label our points. I'll do quadrant 1 with you, and then I will fill in the rest off camera. So I'm just going to go ahead and line up my circles. They got a little bit twisted. There's my 30-degree angle. At the end of that, I should have a point with an x value of 3, square root of 3 halves, and a y value of 1/2. Square root of 3 halves, comma, 1/2. For my other triangle here, at the end of my radius is a point with the coordinates 1/2, comma, square root of 3 halves. Notice my two triangles, this shorter and longer side switches. That is why my x and y values switch, which means when I rotate these, if I do it this way, my x value is -1/2. My y value is positive square root of 3 halves. It's the same as the coordinate at the same height, except the x value has become negative. That's the same as a reflection over the y-axis. So go ahead and fill in the rest of these coordinates, use the triangles or use the properties of reflections, that's up to you. And then I will come back on screen with all the points filled out. Okay, I adjusted the lighting a little bit as well, so hopefully it's a little bit easier to see. So we have here our square root of 3/2 on the x values of all of our pi over 6, multiples of pi over 6. The square root of 3/2 is first. On all of our multiples of pi over 3, you should have the 1/2 first. Now there's 4 points that we haven't labeled on our unit circle, and those are the ones that we don't really need triangles for. That would be here, 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 and here. Because our radius is 1, we know that going 1 unit directly right of our units or of our origin takes us to the point 1, 0. 1 unit directly up takes us to 0, 1. Directly to the left is -1, 0. And directly down will be 0, -1. All right, that's all of the kind of critical values of the unit circle that you'll need to know. There are a lot of tips and patterns and tricks and things like that. So the more you play with this, the easier it will become to remember certain values. Some people like to write their radians on the inside here as well, so that you have your radians and degrees on the same circle. And the reasons we have these on circles and not just printed on a piece of paper is so that you can rotate these and start seeing, like, what are the patterns when I line up certain ways, and what's happening with those. And oh, well, when the red lines line up again, that is one 90-degree rotation. Notice my axes lined up again, things like that. So there are a lot of properties that you can start to notice as you play with it. So I think this is a really good activity to help understand the parts of the unit circle. The next step that we already discussed in class is recognizing that when we're looking at the unit circle, we're looking at the coordinates, where x is cosine of the angle, which we'll call theta, and our y value is sine of theta. And the reason I really like writing it this way is that it really drives home that it's the x value and the y value on the unit circle. It's also alphabetical order, so that's nice to help you remember which is which. This is by no means the end of learning the unit circle or being able to use the unit circle, but it's kind of a nice review and in-depth look at understanding the unit circle and where everything comes from. So we will continue to build on this. I like to put this at the front of my notebook. Maybe I'll 3-hole punch it and have a little paper clip for the triangles. But that's up to you. And I'll see you in class.